Okay, so we will be looking at a simple encryption problem, which is Edabit's encryption scheme. So it's an English text that needs to be encrypted. So first the spaces are removed from the text, and L is the length of this text. The characters are then written into a grid whose rows and columns have the following constraints. So for example, the sentence, "If man was meant to stay on the ground, God would have given us roots." After removing spaces, the length would be 54 characters long. The square root of 54 is between 7 and 8. So it is written in the form of a grid with 7 rows and 8 columns. So it will look like something like that. And we have two constraints to respect. It's that the rows times columns is always bigger or equal than L, and if the rows times column are not satisfying this constraint, we will take the minimum of this two values and increment it to make it satisfy this constraint. So for example, if we took 3 and 4 and the square root is 15, so 3 times 4 is basically 12, which is not bigger or equal than 12. So if we would take the minimum, which is 3, and increment it by 1, it's become 4, and 4 times 4 is 16, which is successfully satisfying this constraint, because 16 is always bigger or equal than 15, yes. And the encoded message is obtained by displaying the characters in a column, inserting a space, then displaying the next column and inserting a space, and so on. So for example, this text, it will be converted into this one, and what we did, it's just reversing this grid and taking line 1 space line 2. So for example, if we took this string here, so it's just IMTGDVS, it's just like that. So we basically have 4 steps to go on. Okay, the first step is extracting the rows and columns, building the grid, reversing the grid, and encrypting the message using the reversed grid. There is actually a very short solution to this challenge that uses just some arithmetic operations between indexes, but we want to go step by step and create some functions or methods that can be used not just for this specifically exercise, but you can use them for any other exercise except the main function, which is encryption, that we will be just used especially for this challenge. And we'll be looking for just some other examples to test our function. Okay, here we go. Now we have the main test functions, which we'll be using for testing our steps. So basically we will have a we have a test 1, which is step 1, which is extracting rows and columns. This is step 1. Okay, for test 2, it's the step 2, which is generating the grid. Okay, void test 3, and this step is reversing the grid. And finally, test 4, is encode the message. Okay, we will be all testing on this string. okay, which will take it from here. Okay, it's a string. Okay, so let's imagine a class that will do the job for us. It's challenge, and we will have for each step a separated method. So it will be a static method, static. Okay, the first one, which will extract the rows and columns, it will be an integer array that we will get the dimensions from it. So we just wanna give this the string, the message, and it will generate for us. Okay, it's a new integer with 2 in length, just 2 values, rows and columns, and we will return this. Implement it later. So, and the next step would be the generating of the character map. Let's get grid from the message as well. Okay, it's gonna be okay, it's char red value, choose a new char. Okay, we should actually give us some dimensions, so we'll just go in binary for now. We'll return red, and for the third step, just a simple method for reversing our given map for grid, reverse grid, and it will be a character grid. So it's gonna be the same as this one, no change. And the final main task is the encryption, string encryption. Take the message. Okay, red equal blank message just for now. Return this return value. So basically these are all the methods that we will be needing in our exercise. So here we're just gonna use them even if we didn't implement them yet. These are just for making our tests ready. So for the test one, we will be looking at an array of dimensions. Okay, dimensions. And this dimensions, it will be taken from get dimensions, and we will give them the message. Just a simple display message, which is rows equal and columns equal, and here we got dimension 0 for rows and dimension 1 for columns. Okay, sorry, it's 1 brackets. Next task is bring in the map grid called challenge point get grid from the message. Okay, and we should be able to display it by a double for loop. It's grid point length I++, and another for with G. For the columns, it's G, and G, and here we got to loop through the line, and we're gonna display, but without a line return, the grid I and G, and we will separate it by a blank return to line. Test 3, I think it will be the same as this one. Just here get Okay, reversed air grid, reversed grid, and here we're gonna give it the grid. Okay, it will be our grid here, here, and here. As simple as this one is the challenge point encryption of the message. That's it for our tests. So these are the steps that we will need to execute in order to test our code step by step. So we'll be implementing the dimensions steps. So okay, first we will need to remove all spaces from the message. So it's gonna be m equal m print replace all spaces with none, just for now. And then we're gonna have the length, which is m point length. Okay, the row. Okay, this is rows. Are gonna be the math point floor of the math point square root of the length, because we need to take the minimum value, which is the minimum value of the interval of the square root. So for example, if we got a square root of 8.5 for example, so the math point floor will be 8. And for the row, the columns, okay, we're gonna be looking at the math point 3, and this one is doing the opposite. So if it's 8.5, it's gonna be 9. And now we just need to test our constraint, which is the multiplicity of these rows and columns, if it's not bigger or equal than length. Okay, then we're gonna need to take the minimum of this red 0 and red 1 rows and columns and test if the red 0 is the min, and increment it, sorry, 30 plus plus, else the red 1 should be incremented. So that's it for our first function. So let's test it. Test 1 is ready, you just need to specify that it's test 1, run. Okay, it's 7 and 8, it's the same as the exercise here with 7 and 8. So just it's just a single test case. We don't actually know that it's working. So, but for now, we will just assume that it's working for all test cases and move on to the test 2. So the test 2 will be generating the grid. Okay, for generating the grid, okay, for now we just need to replace all the spaces with none. Okay, if we do it here, we will not be using it here because this method will be using this one. It's dependent on it, because for creating our grid we need, of course, our dimensions. So dimensions, it's get dimensions of the message, and here we're gonna initialize it. Okay, sorry. Char is gonna be dimensions of 0 and dimensions of 1, which is represented by rows and columns, and our double for int e equals 0. Okay, red point length e plus plus, and the second for in g equals 0, g less than red I point length g plus plus. Alright, so we're just gonna be using try for exception ignoring, because there is a case when we will be when the character will be null, and we don't want to test if null, just gonna be trying, and if there's an exception, just passes. Okay, we're just gonna be filling our grid with characters using a character counter. This is gonna be read ing equal message point char add counter plus plus, just for incrementing characters and bring him to the grid, and we will be testing this by the test2, and that's exactly what we have here. Okay, now passing to the test 3. Okay, for reversing the grid. Okay, it's going to be a new char. It's gonna be a grid. So we're going to take the length of column in the rows and the length of rows in the columns in order to make the reversing. And here, just gonna take this one. Okay, we'll not be needing any try catch for now. Okay, just here we're gonna be using the grid of g and i's for just reverse values. Okay, for test 3. Okay, this is actually the encoded message in a grid mode. So the encoded final result would be this one, space this one, space this one, space this one. So we just need to make it work here. So the encryption method would be just the collection of all these functions. It's just implementing all in one. And of course, taking this replacement and make it here once and for all. Of course, here we're gonna be getting our final grid, which is reversed grid, point get grid of the message, looping through by a 444. Okay, replacing grid by red, red by grid. And here we're gonna be looking at the message. Okay, let's leave this blank for now. Okay, this grid have this output, so we just need to make sure to add spaces. So we're gonna use a string builder, and here we're gonna just convert it to string for just the return type, and here we're gonna be adding a space in advance, and here we're gonna test if the ret I and g is not 0, because we don't want to add a blank character. What did I do here? It's okay, it's char, not end. I'm sorry. No. It's char, it's different, 0. Oh, okay, it's grid. I'm sorry, grid. Everything is good. I didn't screw thing. Okay. Here, grid. Okay. So if it's different 0, we're just gonna append the red ing, and of course, sorry, it's a grid. I don't know why I'm with red. Okay, it's a grid ing, and of course this first space here, it's gonna be deleted by subtracting it, and we're gonna be testing the test 4. Okay, so that's the final message, and that's exactly what it's look like here. So we're just gonna be using these 3 examples for tests, and we should have these. Okay, let's copy this text here and using it in test 5. Okay, copy here. Okay, so that's what we expect. Okay, we will see. We have a test values, and these test values will be this one, this one, and this one. Okay, we're gonna just go through these test values. Test value and test values are gonna be printing encryption of the test values is the result. Test value, and it's gonna be challenge point encryption of the test value. Okay, that's test 5. Gonna run test 5 just to see. Okay, here we got this compared to this. It's the same. Okay, that's what a solution. It may be a little long because it's separated into the multiple functions, but the idea it was to make a function that you can use it not just in this exercise but maybe in other problems to solve. For example, a method that reverses grid. It's maybe useful for some grid exercises if you want to reverse the grid. So this is usable not just in this exercise. Maybe getting a grid from a message 2 could be useful for some other encryption cases, of course, for the dimensions based on a square root 2. The only function that is actually attached to this exercise is encryption, but of course there is a lot more intelligent solutions and short ones that uses mathematical operations in order to wrap all these codes into just a short and simple block of codes, which can be a little complicated. But this step-by-step tutorial is what just to create some type of methods that can be easy to understand and of course can be usable in other cases and following a process of steps. Thank you. I hope this was clear enough, and see you in another problem solving video.